Hello everyone, I'm going to talk about 169 sorry, majority elements. Let me double check if I pronounce right.
Majority element.
A majority element, yeah, majority. The question is given an array numbers of size and return the majority element. The majority element is the element that appears more than n divided by 2 times. You may assume that the majority elements always exist in the array. Okay, so this one is okay. So 3 appears twice, so it's majority. And the second example, we have 2. 2 has 4 times, and 1 just only 3 times. So we pick up 2. So constraints is like n is equal to length, right? So the input generators such as majority elements will exist in the array. So could you solve the problem in linear time and in O1 space? This is a follow-up. So we start from the very basic one. So I need to know how many times, right? For this way, we better use like map or set, whatever. Map is good way to checking the current integer, how many times appears, right? Like map. So this is very basic way, and then we call the for loop. Smaller than numbers length I plus plus. Map put current numbers I, or map get or default numbers I, or if not exists, or plus 1 here. And during the for loop, we can have the result to tracking how many times about which one is large. Right, numbers length is equal to this one. So we can separate this one. If map, no, this one. For here, we can check, right? If map get the numbers I, current now, is larger or equal than n divided by 2, we should return the numbers I. Or the result should be this one. Let's see. Oops, is equal to 2. Okay, should, yeah, and cannot be equal. Because this one, we have the, how many numbers about this? 1, 2, 3, 4, 5, 6, 7. 7. 7 divided by 2 is equal to 3, right? 3 is equal to 1, so it will return 1 is not correct, so we need to 4. So this one cannot equal. And for this one is TC is ON, and space should be the ON time. But the question here, this is very easy way to solve this problem. But how about follow-up? How could we solve the problems in the O1 space? So this is where's tricky part here. Tricky part. I think this follow-up questions will improve these problems from the easy way to the medium. So how could we solve this problem? Follow-up. Sorry. We solve the follow up. How could we solve these problems? We use the O1 space. O1 space, okay, so there's a algorithm, which I'm not sure that's name, but we can treat it as a scenario. There's a game. There is a game. Right, team 1, like a member 1. We have the team A, team B, team C. Just lots of people. And team A member, like A1, right? They have the lots of team A member. They have like A1, A2, A3, kind of like lots of people. And for here, team B just have the B1. For C here is C1. But they are represent the same words. Like current here, we can see. So I take this example. We can treat it like 2 means the team 2. And it's team 1. 2 team. Team 1, right? 1, 1, 1, 3, 1. And this is one has the 2, 2, 2. And they are competing each other. So 1 vs 2. So at the beginning, we just so like a scenario like this, team 1 vs team 2. And if at the original, I have the life, right? At life I is equal to 0. And the setup current now is, the first one is like current is 2. So next time, here is 1. I pick up 2 here, and which means current life is 1, team 2. And then we have got the pointer here. I is here. 2 is initialized. This one is equal to 1. And need to competing with the next one. Next one is encounter. Current now is the same team. So which means my life were +1, were equal to the +1. If the same team. And now keep moving for here. So current life will become the life equal to 2. And then keep moving to the next one is 1. Okay, it's not different team, so which means I will get hurt. So not same team. So life I will -1. So it will become the life equal to 1. And then I move to the next one. Okay, I still not the right, so I will keep a -1. So life is equal to 0. And then move to the next. Okay, current now life is 0, right? When the life is 0, we should initialize. Okay, current here life is 0, so we need to set up current team 1 going to the stop. So life equal to 1, and the team number is equal to 1. And going to the next. Okay, they are not the same team life, right? So it will move to here, same time. It's different. Then life will become 0 again. And then I move to the next one. It will initialize again, life equal to 1, and this time team is equal to 2. So we will have the global result to store the which will survive when this everything for loop finish. Then return the result is the team 2. So the major the majority elements will be 2. So let's see how, that is kind of like idea about this one. It also have the name about this specific algorithm. So I would say that's why I say it's a medium, because some algorithm has the name that definitely is kind of like a math problem. So let's see how to implement this. So we have the result, start from 0, and also we have the initial life is equal to 0. Then we for loop in this one. In numbers length, return the result. Okay, so for here, right? Let's see, one time. One space. I didn't create extra space. Now, if the life equal to 0, which means I need to initialize, pick up the team to start the game. So life should be the 1, and the results this means pick up the team is current numbers, and for this one it means life is not equal to 0. So we have to also have the check, right? Current result number whether equal to numbers I if they are same team. So life should be plus plus. If not, life should be minus minus. Yeah, this is the logic about the here. Yeah. Yeah. And for the time complexity about this one, TC is O1, but the space I didn't create extra space, so it's improved to the O1 time. You can see here, right? So 1. Thank you.